Good day, guys. So today we have the mock interview of Asin. He's preparing for IMS Goa, so we'll be just going over some of the basic questions with non-technical and technical, and see how things go. So Asin, your first question is going to be to introduce yourself, and also I'm getting some background
My
noise.
full name is.
If there's any issue that you can solve that.
What about now?
Okay, it's better. Okay, fine.
Okay, it's okay now.
Yeah.
Yeah. My full name is Asin. I'm from Kanyakumari district, Tamil Nadu. My father is a fisherman. My mother is a housewife. I had two sisters and a brother. I have scored 93 percentage marks in my 10th standard, 77 percentage marks in my 12th standard, and accurately 80 percentage marks in my BE graduation. During the pandemic period, I got the chance to taste the life of sailing with my father. I did fishing with him for 6 months. I have faced rough weather, time away from family, 24 per 7 works, all that things that we are facing manhood. So I consider myself unsuitable for merchant navy. My extracurricular activities are I am a football player and I dance well. During my free time, I read books and do some workout.
Okay. So that was a great sort of this thing, and you mentioned that you have already experience with the sea, etc., and that's why you want to come to merchant navy. But apart from this, what else do you want from merchant navy, or what else made you, proceed towards merchant navy? Why not continue the family business?
Because I'm already actually my father don't want me to join as a fisherman. He don't want it. I'm already from this type of living, sea, boat, and I'm a engineering graduate. So I think merchant navy is the right and correct career for me to enhance myself and to enhance my family and career.
Okay, okay. So why do you want to join IMS Goa specifically?
Actually, IMS Goa provides lot of placement opportunities, and the education here is very well, and they have very good infrastructure. They are taking care of their students very well. Very importantly, they are really taking care of every student, especially each and everyone. So that's why I choose science for.
Okay. So now we come to the technical part of things.
Okay.
So tell me the classification of pumps.
Pumps can be mainly divided into two parts that are rotodynamic pumps, positive displacement pumps. Rotodynamic pumps are centrifugal pumps, axial flow pumps. Positive displacement pump can further divide into two parts, which are reciprocating pumps and rotary pumps. Reciprocating pumps are piston pump and diaphragm pump. Rotary pumps are screw pump, gear pump, blow pump.
Okay. So you mentioned positive displacement pumps and centrifugal pump. So give me the differences between a positive displacement pump and a centrifugal pump.
Centrifugal pump works on the principle of centrifugal force, and positive displacement pump works on the principle of positive displacement. Centrifugal pump needs priming. Positive displacement pump does not need priming. In centrifugal pump, we don't use relief valve. In positive displacement pump, we are using release valve. In centrifugal pump, flow varies with pressure. Positive displacement pump, flow does not vary with pressure.
Okay. So now let's move on to the next question. So the centrifugal pump that you have mentioned, give me all of the parts and how it works. How is pressure created? Explain that.
Okay. In centrifugal pump, there is a foot valve and strainer, suction pipe, impeller eye, impeller blades, impeller, volute casing, and discharge pipe. When we start the motor, the shaft is connected to impeller. Due to the centrifugal force, the fluid gets inside the pump through the eye of the impeller. The impeller filled with the water, and the impeller discharges the water radially outwards towards the casing because of centrifugal force. We can see that the volume of centrifugal pump keeps increasing. So first first the impeller imparts kinetic energy to the fluid. Because of the increase in volume, the the pressure increases and velocity goes down. This is how discharge pressure is created at the centrifugal pump.
Okay. So what is the need of that sealing box which we have? Why we need that?
The ultimate purpose is to avoid any leakage.
Okay. So where is it located?
It is located between that shaft and that impeller.
So it will be on between the shaft and where you have the thin, clearance or spacing where your casing is to block that.
Yes,
So
yes.
that's somewhere the leakage is going to come. So that's where it's going to be located. Okay. So I'll move on to the next thing. So explain to me the working of a gear pump.
Gear pump is a type of passive displacement pump. It's worked by the mechanical meshing of gears. When the gear is getting out of the mesh, the area increases. This is how suction pressure is created at gear pump. So the fluid gets inside. It's moved towards the periphery of the pump by trapped by the gears. And when the gears getting into the mesh, the pressure increases. This is how discharge pressure is created at gear pump.
Okay. And then why do we need a relief valve in this?
Because in passive displacement pump, it continuously displacing water. So pressure is not water, fluid. So pressure is keeps on increasing. So relief valve is mandatory. In centrifugal pump, it can only generate the maximum pressure. If, for example, if it's 10 bar, it cannot produce 11 bar, 12 bar like this. That's why we are using relief valve in passive displacement pump.
Okay. So now we'll come on to the engines. So explain the parts of a marine diesel engine 2-stroke.
Okay. Cylinder head, inlet port and exhaust valve, fuel injector, piston rings, piston rod, connecting rod, crossgut bearing, beacon bearing, crank pin, crankshaft, cam, push rod, and rocker arm.
Okay, fine. So now you have mentioned all of these parts and you mentioned a rocker arm. So what is the purpose of the rocker arm and how it works?
The purpose of the rocker arm is to open and close the inlet and exhaust valve by transmitting the motion of camshaft.
Okay. And when it comes to the rocker arm, are they kept directly sitting on the valve or they are kept slightly above? Do we need any clearance over there?
Yes, we need clearance because if there is no clearance, the combustion won't be effective and scavenging also won't be effective.
No. So I'm saying the rocker arm when it is pushing on the valve, is it kept touching the valve or it's kept slightly higher up? And if there is some gap over there, what is that gap called?
Yes, there's a gap that is called tappet clearance.
Okay. And so why is tappet clearance needed?
Because we need some distance between the valve and that rocker arm. That if there is no gap, air can't be go inside, and scavenging also won't be effective.
No. So in this case, the answer is regarding to thermal expansion. So when thermal expansion takes place, if suppose the valve is over here, thermal expansion takes place, it will go up over here. So if my rocker arm is kept at this level only, it will push the rocker arm up and it will keep the valve open, or the rocker arm will push it lower based on where the camshaft is. So if the camshaft is at the maximum position, in that case, it cannot push the rocker arm any more higher up. So it will push itself down and keep the valve open.
Okay.
So that's mainly due to thermal expansion.
Thermal expansion.
Yeah. Okay. So next thing, explain to me the valve timing diagram of a 4-stroke engine.
In 4-stroke engine, the inlet valve opens 20 degree before TDC and inlet valve closes 60 degree after BDC. After that, compression starts. Approximately 10 degree ignition starts and approximately 12 degree ignition stops. Around 40 degree, exhaust valve open before BDC and exhaust valve closes 60 degree after TDC.
Okay. So if you see in this entire diagram, there'll be some periods where inlet valve is open and exhaust valve is open at the same time. Why is this needed? So you understood the
I
question,
didn't
right?
get it.
At some point of
Yes.
time, we have the inlet valve open inside the engine and the exhaust valve, both the valves open at the same time. So why do we do this for some period of time?
Because it for valve overlap,
Hmm.
it is called valve overlap. The purpose of valve overlap is we have to start the engine at any crank position.
Okay, so it's not really because that, it's because when you say a valve, right? A valve cannot be like a switch. It cannot open and close immediately. It will take some time
Okay.
to come down and go back up. So because the valve opening and closing is not instantaneous, because of that we keep a little bit of valve overlap.
Okay.
So it's because things are not instantaneous. That's fine. Okay, so let's move on to the next thing. So what are the types of engines used on the ship? Which one is used for propulsion? Which one is used for power generation, etc.?
Mainly we are using two-stroke and four-stroke engine. Two-stroke engine is used for the propulsion and four-stroke engine is used for power generation. It's also known as generator.
Okay. Okay, so you mentioned two-stroke and four-stroke. Give me the differences between two-stroke and four-stroke.
Okay. In two-stroke engine, we can get one power output by one revolution of the crankshaft. In four-stroke engine, we need two revolution to get one power output. All the four strokes are In two-stroke engine, the crankshaft and camshaft ratio is 1:1. In four-stroke engine, the crankshaft and camshaft ratio is 1:2. Two-stroke engines are bidirectional. Four-stroke engines are unidirectional. The thermal efficiency of two-stroke engine is high. The thermal efficiency of four-stroke engine is less. The overall efficiency of two-stroke engine is less. The overall efficiency of four-stroke engine is high.
Okay, so you mentioned thermal efficiency of four-stroke. Is it lower or higher?
It's lower than two-stroke.
Okay, because I usually yeah, because
And
the
mechanical efficiency is more in two-stroke engine. Thermal efficiency is more in four-stroke engine.
okay, and can you tell me why?
Because the stroke length is less in four-stroke engine than two-stroke engine.
It's also because in four-stroke engine there's a separate stroke for scavenging to take place. So all of the scavenged air can go out and fresh air can also come in.
Okay.
Okay, so what is TBN number?
TBN stands for total base number. It is used to measure the basicity of oil. It is expressed in terms of the amount of milligram of potassium hydroxide present in gram of that sample oil, per gram of that sample oil.
Okay. So when it comes to a vernier caliper, can you tell me how will you take the final reading?
Actually, the distance between by seeing the scale, we are
Okay.
putting that thing in. Actually, I don't know the exact answer.
Okay. So you'll have to find out how
Can you tell
you
me?
get the main scale reading. So there are two scales on vernier calipers, right? One larger scale and one very small vernier scale. So you have to check whether zero of the vernier scale is matching first with the large scale. Let's say it's 3.2 or something. Then you need to check on your vernier scale which line is matching with the main scale. So let's say over there 2 or 4 is reading is the reading on the vernier scale is matching. Then you have to multiply the vernier scale reading with the least count, and then add that to your 3.2 which you got on the large scale. So you have to learn how to take a reading of vernier caliper plus micrometer, that also can come. So these two you'll have to practice out because it has come in the past. That's why. Okay, so tell me about the lathe machine. What are the different operations that I can perform on a piece of stock?
Lathe machine is important machine in workshop. It is used to get the desired shape of the workpiece by doing various operations like phasing, tanning, drilling, milling, tapering, and yes, those types of operation.
Okay.
And threading also.
Okay. So tell me, how does a ship float?
In Archimedes' principle, we know that when a body immersed fully or partially in a liquid, it is uplifted by a force, which is called buoyant force. If that buoyant force is more than the weight of the ship, then the ship will float. If the buoyant force is less than the weight of the ship, then the ship will sink. In the second case, the density difference. The density difference between water and ship is, we know that ship is more denser, but inside the ship there are so much of vacuum and air present in. So if we compare the density between water and air, air is almost 1,000 times lesser density. That's why ship is floating.
Okay. So tell me about the different boiler mountings and what is their use?
Okay. Water level indicator, boiler mountings on water level indicator,
Okay.
pressure gauge, safety valve, feed check valve, blow off cock, fusible buck, and steam stop valve. First, the water level indicator is used to know what water level indicator is used to show the level of water inside the boiler. Pressure gauge is used to show the inside pressure. Steam stop valve is used to open the steam when it is going to the dangerous level. Then blow off cock is used to avoid those sediment scale from to avoid those things. And fusible plug is used to when the water in the boiler is goes to dangerous level to put off the fire immediately. That's what fusible plug is used.
Okay. So you mentioned blow off. It's usually called blow down because it's at the bottom for your settled debris to go out. One more thing you've missed is the scum valve. So any floating debris which is there, it will go through the scum valve.
Okay.
And how will I provide or ensure that my boiler does not implode? Implosion of boiler is protected by which boiler mounting?
Which is protected by air vent valve.
Okay. So tell me, yeah, correct. Okay, that's good. So now tell me, what is water hammering?
When the flow is flowing in a pipe, if we suddenly close that tap, the water will hit it immediately. This is how water hammering happens.
Okay. And then what is steam hammering?
In boiler, we know steam is flowing in the pipe. Sometimes it may get condensed and it becomes water. When we, for example, when the next day we open the boiler, when the steam flows, it hits the water, and because of that, it causes steam hammering.
Okay. Any reason as to why that steam hammering? I need more clarity. You just said it touches the water, steam hammering takes place, but how? So you have to explain what is happening to the volume, where is the vacuum being created, all of that. So basically you had water over here, as you said, this is the water from the previous day, and new steam is coming over here. So steam, as we know, is massively more in volume compared to water. Water is compact. So the moment the steam goes and touches the water, it will get cooled down. As a result, the steam will cool down and it will reduce in volume because as some of it might even condense into water as it is cooled. So this will create a vacuum or a void over here in pressure. So this will suck this water back with high pressure and force into the side where the valve is over here and hit the valve, and that can damage it.
Okay.
So that's the thing. Okay, so now we'll come to the air compressors. So tell me, in terms of air compressors, why do we prefer a two-stage air compressor compared to a single-stage air compressor?
The reason is we can reduce the it improve first of all it improves the works done and it reduces the energy consumption and we can get higher pressure by two stage of the compression.
Okay. So can you tell me, in terms of the graph, how the two-stage is working?
First stage the inlet valve opens and do you want the graph?
Okay, you can send it to me later on WhatsApp then.
Okay.
Yeah.
First inlet valve opens, first stage, then the first stage exhaust valve opens, then isentropic compression takes place, then intercooler saves the works done, work. So if I had the graph, I will tell you properly, but
Okay, it's
without
fine. We'll
graph,
come back to that
I'm
later.
just lacking.
Yeah.
Okay.
Okay, so let's move on to the next part. So in electricals, tell me, what is the type of electricity that is coming to your house?
Actually, which is AC current, alternative current.
Okay.
Al-
What are the parameters of that?
um,
So what's the voltage? What's the frequency?
it's 220 voltage.
Okay.
Actually, I don't know the frequency.
Okay, so that's one thing you might have to check out. So another thing is, all of
Okay.
your household appliances, are they connected in series or parallel?
I think it's parallel. Am I right?
Why? Why would you say, why do you think it's in parallel? What happens in parallel versus series?
If it's series, all will connect in a single line, but in house, lines are dividing in. Some are going to room, some are going to kitchen, some are going to calculating. It is not series.
So you'll have to also check on this answer as
Depend.
well, because the main thing is, in series,
Okay.
if you see series, if suppose one of them is broken, it cannot continue next. Power is broken in there.
Okay.
But parallel, if this
Okay.
one is broken, let it break. These two will be running normal. So that is
Yes.
one kind of a thing. Secondly, in when you have it in parallel, your 2 points, your main point and your end point, are both the same. So you have a potential difference also, which is constant for all. So all of your appliances will get 220 volt, 220 volt, 220 volt, 220 volt. One will not get 500 volt, then will not get 100 volt. That will not happen. So you'll have to also prepare on this question. And then another question can be also, why is the current that is coming to your house AC current? Why not DC current?
Because basically we can transfer AC current from one place to another. We can transfer the longer distance. Also, the electrons can flow either direction, forward or backward. But in DC, only we can store that power. We can't transfer it one place to another.
Okay. So the next question is, during your BTech, which were your two
Yes.
favorite subjects from the all, from all of the 4 years or 8 semesters?
Yes. First is internal combustion engines, and second is refrigeration and air conditioning.
Okay. So since refrigeration, you say, was your strong point in BTech as well, so give me the entire VCRS cycle.
Okay. The low pressure and low temperature vapor refrigerant from evaporator goes into compressor, and it get compressed. The isentropic compression takes place as compressor. After that, the refrigerant becomes high temperature, high pressure, superheated vapor. That high pressure, high temperature superheated vapor goes to condenser. Here, isobaric condensation process takes place. The temperature reduces slightly and the pressure is same, and it becomes saturated liquid. It goes to dryer. Dryer is used to remove all the moisture present in the refrigerant. After that, the refrigerant go to thermostatic expansion valve. Here, isentropic expansion process takes place. It acts like an orifice. So here, both pressure and temperature get reduced because of sudden increase in volume. It also regulates the flow of refrigerant. After the thermostatic expansion, the refrigerant is in the form of mixture state, 80% liquid and 20% vapor. It goes to evaporator. In evaporator, isobaric heat absorption process takes place. When it absorbs heat, all the refrigerant becomes fully vapor. This is how this is how cooling produced, and it goes to compressor. Before compressor, there is a sensing bulb. It senses liquid because if liquid present in refrigerant, it damages the compressor. To avoid that, sensing bulb senses that and give the signal to thermostatic expansion valve via capillary tube.
Okay. So what about viscosity index? What is viscosity index?
If the viscosity index is high, when we heat the temperature, the viscosity will slowly reduce. If the viscosity index is less, when we heat that fluid, the viscosity will suddenly decrease.
Okay. So interesting. Suddenly you can say more rapidly or quickly or easily.
Okay.
Because suddenly means you're saying that there will be like drops. It will just be quicker. We're not sure if there will be drops or not. So you can just switch the word suddenly with something like rapidly or quickly.
Rapidly, quickly, okay.
So this particular thing of viscosity index, how does it help us on a ship?
Our fuel has higher viscosity index
Okay.
because we have to heat that fuel oil for higher thermal expansion.
So
Am I right?
right now you're saying that your fuel oil has high viscosity index, and we know that the heavy fuel oil which is there is like somewhere around 380 centistokes. So if I heat it with high viscosity, it will keep on remaining 380, 370, 380, 370 and it will clog all of my injectors, etc. So I wanted to drop quickly and come to 13, the value of 13. So that will not have any relation to this, but mainly it is in your coolants for your winches, etc. on the deck or any other machinery on the deck. So the coolant which is there in them, that should have a high viscosity, this thing. So that when temperature drops outside, you're in some Arctic region or something, that should not freeze immediately.
Yes.
So that is mainly where the use case comes from. Okay, so can you tell me about the induction motor?
Induction motor has a stator and a rotor. When we give the AC supply, first of all there are two motors. One is single phase and another one is three phase. In single phase, the electromagnetic field is produced by single phase AC supply. In three phase induction motor, the electromagnetic that rotation is produced by three phase AC supply.
Okay. So what law is it based on? How is that rotational force being created?
Okay, when we switch on the induction motor, the current supply goes to the stator, so it creates magnetic field inside. So we know that North Pole and South Pole retract. So this is how rotation takes place inside the motor.
Yeah, so it's not really about retracting and all. You need to first talk about the construction, that you have three coils with 180-degree angle between them. When the AC current is flowing through them, because of AC, you know how AC is a sinusoidal wave, and this three pattern, you will get the final result as a rotating magnetic field. So now you have a magnetic field that is rotating, and this can be controlled by the frequency of your AC current. Now, once this is done, you have your squirrel cage, which is basically a long cage with some thin rods all around. Now, what happens is this rotating magnetic field will be cutting those lines on the squirrel cage, because imagine one rod and if the magnetic field is rotating, there's some changing magnetic field applied to that. So that puts a EMF to be generated in that, and then from there on you can proceed with the answer. So you'll have to come from all of these steps and not just say like magnetic is repelling or something that way. That wouldn't make sense for this particular answer.
Okay.
So that's not the answer that you'll have to prepare. Okay, so
Okay.
last part is going to be, let's see what else we have here. Okay, so why do we switch our refrigerants from the older ones to the newer ones?
Maybe the older ones makes noise, and it it's not producing the refrigerator effect that we need. That's why we are switching older one to newer one. Maybe the
So
components
actually,
in the
when I say
older
older
one
to
get
newer, I'm
them.
talking we are switching from like R22 or something to R134 in that type.
Older refrigerants are older refrigerant has higher ozone layer depletion point that are not economic, not friendly. That's why we are switching that refrigerant from older to newer, like R134A, R125, R404A, R407C.
Okay. So your final question is explain the exhaust gas turbocharger.
Okay. The exhaust gas turbocharger is run by exhaust gas. The gas from the exhaust gas manifold goes to the turbine. It rotates the turbine. The turbine and the blower is connected in the same shaft. Because of that, the blower increasing the pressure of the air. It goes to the intercooler. Intercooler reduces the efficiency. Intercooler reduces the temperature to increase the efficiency. The ultimate purpose of turbocharger is to provide more air for better combustion and better efficiency.
Okay. So after the turbocharger, do we have any more components?
Yes, we had that intercooler.
Okay, so you're calling it intercooler, but or else it's just a cooler also. You can say, which we
Okay, okay.
why is that needed? But
Because intercooler is used to reduce the temperature to increase the efficiency. If the temperature is more, the efficiency will reduce. That's why we are cooling that air.
it's also mainly to reduce the temperature because we will increase the density of air that we have. So that can help you get a more stronger density of air. So you can push it into the engine with a more density. You can burn more fuel and more power, etc. Okay, so that's it for now. Let me know if you have any other questions. Else, I think you made note and you know like which topics, etc. you need to work on. So we'll proceed with that and then see how things go.
Actually, do you have any feedback for me? How can I improve myself?
Yeah, so just these few questions I told you, right, which you need to work on. It looks like electrical you're not too sure about. You said
Okay.
that you don't know regarding the frequency and how that works, and even induction motor you are not really sure on that. So you can work on these things, and then minor small parts like the tappet clearance, why it is there, mainly due to the thermal expansion. So these small things you can work out from that and then go from there. Otherwise, it's quite good.